Are our students performing better than the national average GPA? Or is the difference just random? Let's say your school wants to know, is our students' average first-year GPA really higher than the national benchmark, or does it just feel that way? We've collected a sample of student GPAs. We believe the national average is about 3.0. Now we're asking, is the difference real, or could it just be due to random variation? That's where the one-sample t-test comes in. Let's explore when to use it, what it tells us, and how to run it from start to finish. Our research question is straightforward. Is the average GPA of our students significantly different from 3.0? That 3.0 might represent a national benchmark, an institutional target, or just a reference point we want to test against. So how did we decide this was a one-sample t-test and not a z-test or something else? Here's our logic. We're comparing a sample mean to a known value, in this case 3.0. But unlike the z-test, we don't know the population standard deviation. Instead, we estimate it from the sample itself. Our sample size is moderate, not huge, but not tiny. That makes the one-sample t-test the right tool for the job. Let's flash to the method map to show how we got here. We see we are testing a hypothesis, we have a known or hypothesized value, and that value is continuous, and in this case, might feel the sample size is smaller. But, more importantly here, we likely do not know the population standard deviation. The t-distribution accounts for that extra uncertainty. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses. Then we want to define your variables clearly. What's the outcome? What's the grouping variable? And how are they coded? From here, describe your data preparation steps, including how you filtered, recoded, and structured the data. Next, want to explain the method you're using and how you calculated or entered group proportions. We should also mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. The one-sample t-test gives us three main pieces of information. The sample mean, so we know where our group stands. The t-statistic, which tells us how many standard errors the sample mean is from the comparison value. And the p-value, which tells us how likely we'd get a result this extreme just by chance. It also gives us a confidence interval, which shows the range of plausible values for the population, mean based on our sample. Let's jump into SPSS and run the test. Go to Analyze, Compare Means and Proportions, One Sample T-Test. Select your dependent variable, in this case, GPA, and enter your test value. Here we'll use 3.0 as our comparison mean. Click OK, and SPSS gives us the output. Let's look at the key results. The sample mean GPA is about 2.75. The t-statistic is negative 10.1, which that t-value convert to. The p-value is less than 0.01. If that p-value is below 0.05, we reject the null hypothesis and conclude that our student's GPA is significantly different from 3.0. We can conclude then that our GPA overall is lower than a 3.0 base. So there you have it. The one-sample t-test. It's your go-to when you're comparing one sample's mean to a known value and you don't have the population standard deviation. Next up, we will start looking at a different type of input structure, staying with the core target variable setup. If you're enjoying this series, make sure to subscribe and follow along as we keep building from one method to the next.